Hello, everyone, and welcome to the second lecture for the EdSofta Chemistry JAMB UTME tutorials. So, in this lecture, well, let's start with once again. I want to talk about what EdSofta is and what EdSofta stands for. EdSofta is this tutorial is powered by EdSofta. EdSofta is an app. EdSofta has apps that prepare students for JAMB UTME, WAEC. It has past questions, study materials, and many other features that help students prepare for exams. For this tutorial, we'll be solving questions from the EdSofta app. This is Google Play on your. So for you to download the EdSofta app, you can go to Google Play, search for the app, and it will come out. You can click on it, install it, and for you to use the full features, you need to pay a sum of 1,500. Then then you can do that again. You can download the one for the Windows for the desktop for the same amount. For then you can do that again. You can download the one for you so for the same amount of 1,500, you activate it and you have access to all the features of the app. So we will be talking about a very calculative topic today, and some of us were asking the topics that we are going to look at. So the topics we're looking at is we've looked at the first one, balancing of equations, mole fractions slash mole ratios. That's mole ratios. What we're looking at now, electrolysis and equilibrium. So these are the four topics that we're going to be looking at today on our chemistry tutorial. So you can move on. So we can move to the topic of today. So mole ratios. So now this mole ratios is similar to the last topic. Like I said, the reason for the last topic was just for us to understand that that we need we need a balanced equation. So the use of a balanced equation is for us to solve some equations based on the mole ratios that we get, and we can't get accurate mole ratios if we don't have if we don't have we can't get accurate mole ratios if we don't have we don't have the the if we don't have a balanced equation. So from what you can see, the numerical coefficient of a balanced equation represents the number of moles of reactants and products. From this coefficient, we get the mole ratio of the reactants and products in the reaction. So look at this reaction here, H2SO4, to give us the ionic form of hydrogen plus a radical, which is SO42 minus. And you can see that we have a mole ratio, an accurate mole ratio. Why? Because we have a balanced equation. So with that mole ratio, we can use it to solve some of the issues that we have. So, and also we have a formula there, number of moles is equals to reacting mass over molar mass. So like I said at the beginning, calculative this is a more calculative topic, so we are not going to be spending much time on the slide. Instead, we will even just be solving questions. So we'll just be solving as many questions as you can solve for this topic for now, for like the next 30 to 40 minutes. So I will be opening the EdSofta app now so that we all can use the app and see the resources of the app. So I'll be sharing the app screen now. Okay, so we have, so like I said, so this is what the EdSofta app looks like. we have practice exam, we have practice exam, we have practice exam, we have play games, we have save questions, we have search for tutor, we have join forum, we have a lot of features that you can use. But for the sake of this, we'll just be looking. So we are going to be going to chemistry, we are going to select topics and we'll select chemical combination because that is the theme under which mole ratios is, so that we can see some questions and solve some questions. So I would just submit. So this is the interface of the app. This is exactly what it looks like. So we're just going to be solving as many questions as we can solve. We might even solve all these 40 questions. Just solve as many questions as we can solve, so as to so that we can see so that we know that we are. So let's look at the first question. The first question here says that during a titration experiment, 0.05 mole of carbon dioxide is liberated. What is the volume of gas liberated? So now, in this case now, we don't really need an equation, but what we know is that they liberated what? Carbon 4 oxide. So what we just need in this case now is to know what we call the molar volume. So I'll be putting this up on the board and solving it for us on the board. Okay, so when you submit, so this is what it looks like. So we can even see the answer, you can see the explanation. So we're putting up the screen now. So hope we can all see this screen now. So the first question that we have, during the titration experiment, so this is what the the practice scheme looks like. So you can see the question, you can answer the question. Well, this is a submitted version of it, so that we can just see. So you can save a question. You can, if you are doing maths, you can load the calculator. If you feel there's an error, you can also submit. You can also report the error. You can report the error. You can report the error if you feel that there is a you can report the error. So please hold on. Okay, so you can also view results. I just submitted, I didn't solve anything. So you can view results. Since we only picked chemical combination as a topic, so we only get chemical combination. So So now let's go on. During the titration experiment, 0.05 mole of carbon dioxide was liberated. What is the volume of gas liberated and the molar volume? So in this case now, all you have to do is, if you can see my screen, you can see the explanation. All you have to do is to just use, so I'll be switching the screen to the board so that we can solve this question together. So they are saying during a titration experiment, 0.05 mole of carbon dioxide is liberated. What is the volume of gas liberated? So how do we solve such a question? So all we have to do is, we know that based on some laws that, so let me just switch screen. So the question was telling us that during a titration experiment, 0.05 mole of carbon dioxide is liberated. What is the volume of gas liberated? So what we have is that 0.05 mole is liberated. Now, from what we know that we know that we know that 1 mole of a gas is the same thing as 22.4 dm cube at STP. So the volume of gases at STP is 22.4 dm cube. But now you are asked for what? The volume liberated of 0.05 mole. So all you have to do is to do what? Is to cross multiply. It's proportion. Note, it is easier to solve your chemical equations like this with proportion. So how do you do this? You cross multiply. So if you cross multiply, you know that x times 1 will be equals to 22.4 times 0.05. And x will be what? 22.4 times 0.05 divided by 1. And your answer will be 1.12 dm3. So the question was quite easy. This question was quite easy. They said during a titration experiment, 0.05 mole, during a titration experiment, 0.05 mole of carbon dioxide is liberated. What is the volume of gas liberated? And they gave us the molar volume of the gas at STP is 22.47, 22.4 dm3. So all we just need to do is to just get the question, and we continue get, all we just need to do is just apply proportion. As you can see, that 1 mole of gas is equal to 22.4 dm cube. Therefore 0.05 mole will be equal to x at STP. So once you cross multiply, and you can find your x by just multiplying 22.4 times 0.0105, and your answer will be 1.12 dm cube. So let's move to another question. So we can move to another question. I'll be switching the screen back. Okay. Okay, so if you can see this, you will see, so you see that the answer to the above question is 1.12, as we got in our calculation. So let's look at the other question. Okay, this is not a more ratio question. Okay, percentage by mass, which we all. Okay, so let's look at this question. Question says that 24 grams of magnesium reacts with dilute hydrochloric acid. Calculate the volume of hydrogen gas involved at STP. Now, like I said before, it is very important for you to know your formula. And one of the things that will help you to know your formula is when you know to know your symbols. One of the things that help you to write your reaction is if you know your symbols. So now look at this question now. Magnesium reacts with dilute hydrochloric acid. So how do we represent this equation so that we can get the mole ratios that will help us to get our answer? So all we have to do is, I'll be going back to the board. All we need to do is this. So all we need to do is just for us to go to the board and just say, so from the question, 24 grams of magnesium reacts with dilute hydrochloric acid. So let's write the equation first. Let's write the equation first. So the equation will be magnesium plus HCl. Now this is going to give us MgCl2. They said it liberates hydrogen plus H2. So now, because I know this one, I know that, okay, that means magnesium is going to displace the chlorine and the hydrogen will be alone. I know that is what is going to happen in the reaction because I know my symbols. I can now what? I'm now able to solve the equation that we have at hand. So now, what would be our mole ratio? Is this balanced? No, because this is Cl2 and this is H2. That means for us to, there are two Cl here and two H here, but we have one H here and one Cl. So how do we balance this equation? All we need to do is to do what? To put 2 here, so that this will become 2H and 2Cl, and that will be all. Now that we know the equation, what is our mole ratio? Our mole ratio will be 1 to 2 to 1 to 1. Now let's go back to the question. The question says 24 grams of magnesium reacts with dilute hydrochloric acid. Calculate the volume of hydrogen gas involved. So we are calculating the volume of hydrogen gas involved. Now, if you look at it, they said 24 grams of magnesium reacts with this thing. So how do, first we have to know, so since it's 24 grams, so all we do is we come back so let me come back to the board. So what we can just do is, we know that this is 1 mole from our what? 1 mole of magnesium is going to give us 1 mole of what? H2O. H2. And we know that what? For gases, volume of gases at STP is always what? 22.4 dm3. So we know that since we have 1 mole of H2, we know that 1 mole of H2 is going to give us 22, is the same thing as 22.4 dm cube of H2. And based on this our calculation, our answer is 22.4 dm cube. Perfect, and that's all. So you see, now the question you ask is, how did I get this 1 mole? So now, how I got this 1 mole was that from the question they said 24 grams of magnesium. So that means the mass of magnesium is 24 grams. So if the mass of magnesium is 24 grams, how do we find the number of moles? We know that mole is equals to mass over molar mass. What is the mass that they give us? 24 grams. What is the molar mass of magnesium? 24 grams per mole. What is our answer? 1 mole. So that's how I knew that what they used what 1 mole of magnesium. So how do we now get the volume of hydrogen? From our mole ratio, we know that 1 mole of magnesium will give 1 mole of hydrogen. So if it was 1 mole that was here, if it was 2 that was here, it would be 1 mole of magnesium will give 2 moles of hydrogen. But because it is 1 mole that is here and 1 that is here, it is 1 mole of magnesium that is giving us 1 mole of hydrogen. So this 1 mole is now what we can now liken based on the volume that we know that based on what we know, that 1 mole of a gas is always going to be 22.4 dm cube, is always going to be 22.4 dm cube at STP. Don't forget, at STP. So 1 mole of H2 is equals to 22.4 dm cube of H2 at STP. So that is all. That's how we solve the question. That's how we solve the question. So let's look at another question and see what we can do. See what we can do. So that is all. That's how we solve the question. That's how we solve it. Okay. Okay. So let's move to the next question. Let's look for another question. Oh, wow. So let's look at this question. So this question is, wow, so they were generous enough to give us a balanced equation. So let's write out the equation and then see whether we can solve the question. Okay, let's look at the question. So we have Na2CO3 plus 2HCl. I think it's going to give us NaCl plus H2O plus CO2. I think there's a 2 here. Okay, so we have the equation. So what's the question? How many moles of triazocarbonate 4 are there in 25 cm cube in a 25 cm cube solution, which require 10 cm cube of 0.05 0.0 mole per dm cube hydrochloric acid solution to neutralize it? So we are finding the moles of sodium. We are finding the moles of, so now this question we don't really need to go so far. So first we need to first write our mole ratios. So what's our mole ratios here? We have 1 to 2 to 1 to 1, no, to 2 to 1. Now the formula that we'll be using to solve this type of question is going to be, so first we need to first find the concentration. It's the concentration that we can now convert to mole. But the formula we'll be using will be, this is a typical titration question where you have CAVA over CBVB is going to give us Na all over Mb. Now this Na all over Mb are your mole ratios. So for the acid, we know this is the acid and this is the base. So what is our Ca? Our Ca, from what they gave us, let's check it, is, our Ca is 0.05, 0.05. Our CA is 0.05, our VA is 10, our CB we don't know, that's what we are trying to find, and our VB is 25. So what would this look like? We are looking for what? CB. What would this look like? This will look like 10 times 0.05 all over CB times 25. What is our CA? 2, and our MB? 1. So we have 0.5. I've multiplied 10 by 0.05. 25 CB is equals to 2 over 1. So we know that we have 0.5. We can cross multiply, is equals to 2 times 25 CB. That 0.5 is equals to 25, sorry, is equals to 50 CB, and CB will be 0.5 all over 50. And what do we have? What will be 0.5 over 50? We have 0.01 mole per dm cube. But we are not done. This is our what? CB. Now, how do we now find our main answer? Oh, it seems the question just needs us to find the mole per dm cube. The question just needs us to find the mole per dm cube. So now we have our CB. So this is our answer. Our answer is 0.01 mole per dm cube. But the question could have gone forward. Sometimes they ask you to find, the question is asking us to find number of moles, but the answer is actually in the concentration. But sometimes you are asked to give, so how do you find it? What you need to know is that N is equals to CV all over 1000. If your volume is in cm cube, note, if your volume is in cm cube, if your volume is not in cm cube, V, it will be if your volume N is equals to CV if your volume is in dm cube. So all you just do is put your CB, which you have here, put your volume, which you have, divide by 1000, and you have your what? Number of moles. So as you can see, this balance equation that they've given us already helped us to get the what? The mole ratio. And with the mole ratio, we're able to apply the formula for us to what? Find the what? The correct concentration. Now let's look at more questions. So you can see it is very important for you to understand how how to get a balanced equation, what a balanced equation is, and how to get the mole ratio, and how to move on after getting the mole ratio. So let us move on. So let me okay. Okay, so let's look at this one. What volume of oxygen is produced from the decomposition of 2 moles of KClO3? What volume of oxygen is produced from the decomposition of 2 moles of oxygen? So what do we do? So for this one, what we just need to do is to first write the reaction for the decomposition of KClO3. What is decomposition? The you have when you have a very well, it is the breaking down of a compound to smaller compounds, basically breaking down of a compound to smaller compound. Now KClO3 is like this. Now, when KClO3 breaks down, it breaks down into KCl and O2. But this is not a balanced equation. So how do we balance the equation? We put 2 here, we put 2 here, and we put 3 here. Yeah. Why? So that what? This becomes 6, we have 6. This becomes 2, 2, we have 2, 2 here also. So now, we have this. Now, let's go back to the question to see what the question is asking us to find. They said what volume of oxygen is produced from the decomposition of 2 moles of KClO3. Now, this, the ratio of this is 2 to 2 to 3. 2 to 2 to what? To 3. So what volume of oxygen is produced from is produced from decomposition of this? So now this is very simple. You know that what? 1 mole, everybody, we hope we don't forget, we know that what? 1 mole, we know that that means that 2 moles of KClO3 is going to give us what? 3 moles of O2. But now we all know that 1 mole of O2 is what? Is 22.4 dm cube. So all we have to do is, if 1 mole is 22.4 dm cube, they are talking about volume, so you know that your molar volume must always come up. How much will 3 moles be? So 3 moles will be what? X. So what do? We just what? Cross multiply. And what is it? X will be what? 3 times 22.4 dm cube. And your answer will be 67.4 dm cube. That's all. So this is pretty straightforward question. Now, what is very important is you knowing the reaction, you knowing the how to write the reaction equation, then you knowing how to balance the reaction equation, then you can get your mole ratio, which will then now enhance you for you to be able to solve the question. So let's see if we can look at a couple more questions. So we have a very nice question here. Let's see if we can solve it. They said, what volume of gas is evolved at STP? What volume of gas is evolved at STP if 2 grams of calcium chalcocarbonate 4 is added to a solution of hydrochloric acid? If 2 grams of calcium chalcocarbonate 4 is added to a solution of hydrochloric acid. So what volume of gas is evolved at STP if 2 grams of calcium chalcocarbonate 4 is added to a solution of hydrochloric acid? Okay, let's move on. So how do we solve this? First, we know that the reaction is between calcium chalcocarbonate 4 and hydrochloric acid. The reaction is between calcium chalcocarbonate 4 and hydrochloric acid. So let's write the reaction first. Okay, so let's check. Is our equation balanced? No, because of the what? Hydrogen. See, you have 2 hydrogen here, 2 Cl2 here. Very simple. What do? You just add 2 here, and we have a balanced equation. So what do? You can do this. This is our what? Mole ratio. Now let's go back to the question and see if we can solve the question. So they told us to find the volume of gas evolved at STP if 2 grams of calcium chalcocarbonate 4 is added to a solution of hydrochloric. So we are finding the volume of gas liberated if 2 grams of calcium carbonate 4 is added to the solution. So, so we know that what is 2 grams of CaCO3. Now, note the gas that is going to be liberated is the gas that is going to be liberated is CO2. CO2 is the gas that is to be liberated. CO2 is the gas and what do you mean by liberated? You know when you buy your Coke or you buy your Pepsi, you open it up and hear a fizzing sound. That fizzing sound is CO2 being liberated as you open it. So that's exactly what will happen at the end of this reaction. There will be a fizzing sound of a gas being liberated, and that gas that is to be liberated is what? Is what? CO2. The gas that is to be liberated is CO2. All right. The gas that is to be liberated is CO2. All right. Okay. So now we need to solve the question. So what do? We know we have 2 grams of CaCO3, but we know that based on this, we know that what 1 mole of CaCO3 is going to give us 1 mole of the gas CO2. But now take cognizance that what we are not using 1 mole to react, we are reacting with just 2 grams. So we need to change these 2 grams to mole. So how do we change these 2 grams to mole? Changing the 2 grams to mole will mean that we are going to do what? We are going to say we know that mass, because this is mass, is equals to mole all over molar mass. So what is the molar mass of CaCO3? The molar mass of CaCO3, as we all know, is going to be adding all the elements together, the mass numbers of the elements together. So for calcium, we have 40, for carbon, we have 12, and for oxygen, we have 48. At the end of the day, we have what? 100. At the end of the day, we have what? 100. We have what? 100. So we now do, so what we can now do is what? We know that what? The mole, sorry, I said mass is equals to mole over molar mass. Sorry, mass. Mole is equals to mass over molar mass. Mole is mass over molar mass. So the mole will now be 2 grams, which is the mass, all over what? 100, which is 0.0. We have the mole. So we know that what? 0.02 mole of CaCO3 is going to give us the same amount of mole because it's 1 to 1. So if this one is the same thing that it gives 0.02 mole of what? CO2. So what do we now need to do? What we now need to do is to do what? Is to now say that we know from our chemistry, from our elementary chemistry, that 1 mole will give us 22.4 dm cube of the gas at STP. Abi? So 0.02 mole will now give us what? X. So how do we find the X? We can cross multiply. X times 1 mole is 22.4 times 0.02. 22.4 times what? 0.02. And that will cause what? That will cause us to have 0.448 dm cube. So our answer is 0.448 dm cube. Or we can put in cm cube as 448 cm cube just by multiplying by 1000. So you see that This is not what is very important, very, very important is you balancing the equation, then you writing out the mole ratio. Then with the mole ratio, you can now begin to what? Solve the question. You can now begin to solve the question using your formula such as mole is equals mass over molar mass. Also understanding that 1 mole of a gas is 22.4 dm cube at STP, and also your Avogadro's constant too, where you know that 1 mole of a carbon of any substance contains what? 6.02 times 10 raised to the power 24 at 23 atoms, particles, electrons, neutrons, as the case may be. So let's move on. Let's move on. Let's see if you can still answer one or two questions or one more question before we call it a day. So you can see this question. I don't think I really need to answer it. So what you I don't need to, so what you can see that they said 2Na plus 2H2O to give NaOH plus H2. So we should find the sodium mass of sodium hydroxide produced by. Here, as usual, you should always know the word mole ratio. And based on the mole ratio, you can now find your answer. So always note, get your get your always make sure to get your your balanced equation, bring out the mole ratio, and with the mole ratio you can find a way to solve these questions. With the mole ratio you can find a way to solve these questions. With the mole ratio you can find a way to solve these questions. So like I said before, this tutorial is brought to you by this tutorial is brought to you by EdSofta, and EdSofta is a tech company that that is a tech company that EdSofta is a tech company that specializes in tech solutions for in tech solutions for for in tech solutions for for education. So you can practice exam, you can go over there, lots more questions on this mole ratio on our app. You can download the app, use the app. You can even, so for you to even get this majority of these questions, you can come to practice by topic, come to chemistry, and make sure you click on what? You click on chemical combination, and you can see all these questions. You can see all these questions. You can even go down to read and learn study materials to pick these questions on chemical combination and learn more about them. The questions are here on chemical combination for you to learn more about them. So we are going to come to an end now here. We are going to resume back in the next 15 minutes. Thank you and God bless you.